Hello everyone, I welcome you all in this C programming and data structures lecture. Here we will discuss one program related to reversing a stack using two stacks. In this presentation we will learn how to reverse all the elements of the stack with the help of two temporary stacks. So without any further delay, let's get started. We are interested in writing a program to reverse the elements of the stack with the help of two temporary stacks. Okay, so we are available with two temporary stacks and we are available with one original stack. We have to reverse all the elements of the original stack with the help of two temporary stacks. Fine, we want to write a program for the same. Now before writing the program, we must understand the problem properly. We must understand the requirement of the problem properly. Okay, here first we will represent these three stacks, right? This is the original stack, this is the pictorial representation of original stack, and this is the pictorial representation of temporary stack 1 and temporary stack 2. We are available with these three different stacks. And let us suppose that these are all the elements of original stack 1, 2 and 3. You can see 1 is at the bottommost place, then we have 2 and then we have 3. Obviously, there must be some top pointer pointing to this element, right? If we try to pop an element out of stack, we will get this element first. Now the target is to simply reverse all these elements. Please remember that our problem is write a program to reverse the elements of the stack. We have to write a program to reverse the elements of this original stack. Okay, and reversing means we will get something like this: 1, 2 and 3. 1 must be the topmost element, then 2 must come, and finally 3 must come. Here, this is the pictorial representation of stack before reversing the elements. You can see the 3 is at the topmost position, then we have 2 and finally we have 1. After reversing all these elements, this is how our stack looks like. 1 must be at the topmost position, then 2 and then 3, right? But how to reverse the elements of the stack by using two different temporary stacks? How to do this? We are available with two different temporary stacks. We will use those stacks to reverse the elements of this stack. Now the idea is to simply pop this element out of the original stack and we will then push this element onto temporary stack 1. So what we will do, we will pop all these elements out of the original stack and we will push them one by one onto temporary stack 1. First we will pop this element from the original stack and we will push this element 3 onto temporary stack 1. So let's do the same thing. That is, we will pop this element out of the stack and we will push this in temporary stack 1. After this, we will again do the same thing. We will pop this element out of the original stack and we will push this element onto temporary stack 1. Okay. This is what we want. We have to pop the element from the original stack and we have to push this element onto temporary stack 1. Then after this, we will pop this element out of the stack and we will push this onto temporary stack 1. Okay. So this is how our temporary stack 1 looks like. Now the original stack is empty. Now we have all the elements inside temporary stack 1. Now the next thing we will do is, after pushing all these elements onto temporary stack 1, we will pop the elements out of this temporary stack 1 and we will push all these elements inside temporary stack 2. This is what we will do next. We will pop the element from the temporary stack 1 and we will push this element onto temporary stack 2. Obviously, this is the topmost element of the temporary stack 1. So after calling the pop function, definitely this element will get popped out of stack. And after calling the push function, this element will get pushed inside temporary stack 2. We'll do the same thing again. We'll pop this element out of temporary stack 1 and we will push this element onto temporary stack 2. This is what we will do next. We'll pop this element and we'll push this over here. Then after this again, we'll pop this element and we'll push this element over here, right? Let's pop this element out of the temporary stack and then push this onto temporary stack 2. You can see the current status of temporary stack 2. These are all the elements of temporary stack 2. 1 is at the bottommost place, 2 is at the second topmost place, and 3 is at the topmost place, right? Now, finally, we will pop all these elements out of temporary stack 2 and we will push them one by one onto original stack. Simple, right? So let's pop this element out of temporary stack 2 and we will push this element 3 onto original stack. So let's push this element. After this, we'll pop this element out of temporary stack 2 and we'll push this onto original stack. Fine. Let's pop this and push this over here. And finally, we will pop this element out of temporary stack 2 and we will push this element onto original stack. Let's do this. So this is the current status of the original stack. 1 is at the topmost position and 3 is at the bottommost position. This is what we want, right? Eventually we want this 1, 2, 3 and we got this with the help of 2 temporary stacks. We have reversed all the elements of the original stack. We can either go for array implementation of stacks or linked list implementation of stacks. It doesn't matter what implementation you will go through. Maybe you can select array implementation or maybe linked list implementation. But for this lecture, we will go for linked list implementation of stacks. Okay. Now, in the linked list implementation, of course, we have to represent all these stacks using linked list, right? First, we have to represent the original stack in the form of a linked list, then temporary stack 1 and then temporary stack 2. And this is how our linked list looks like. This is the original stack. You can see that 3 is at the topmost position. Currently, the top pointer is pointing to this particular node. And you can see this that 2 is at the middle. And finally, we have 1, which is at the bottommost place of the stack, right? Similarly, we can represent temporary stack 1, but currently temporary stack 1 is empty. That's why the top 1 pointer is null. It is not pointing to anything. I'm assuming that top 1 pointer must always point to the topmost element of the temporary stack 1. Okay, this is my assumption. This is just the name I've given to this pointer. And top 1 is currently null, which means that there is no element inside temporary stack 1. Similarly, temporary stack 2 is also null. And I'm assuming that top 2 pointer must always point to the topmost element of the temporary stack 2. Okay, these are all the linked list representations of the stacks. Now, let's try to implement our original stack. Okay, it's very simple. First, we have to declare a struct node. This is important. And we can have a global declaration of top pointer, and top pointer is currently holding null. You can see this. In the main function, we have to call push thrice because we want to insert these 3 elements onto original stack. First 1 must be inserted, then 2 and then 3, right? And this is how our push function looks like. We are already aware about that how this function works, but let me just go through with this function once again. Here, obviously, this push function will receive the data. Initially, this push function is called with this value, that is 1, and this 1 is passed to this data variable. And then after this, a new node pointer is declared which must point to some node. And here you can see that we are calling malloc function and we are allocating the memory for this new node. Then after this, we are checking if new node is null. This means stack overflow, and we will exit from the program with exit failure status. That's what we will do. After this, if this is not the case, if new node is not equal to null, then we will update the data part of the new node by data and link part by null. After executing all these lines of code, we will get our node, and finally we will update the link part of the new node by top. And currently you can see that top is null, therefore the link part will get updated by null. And finally we can update our top pointer so that it can point to the new node, right? So this is how our push function works. We are already aware about this push function. Now we will see the complete code in code blocks. Here you can see this is the complete program. We have struct node, top pointer is declared globally. Then we have this isEmpty function which we will use in the print function. Okay. If top is equal to null, then return 1, else return 0, right? Then we have this push function. And we have this print function also to print all the elements of the stack. First temp pointer is declared. Then temp is initialized to top. Then we will check if is empty. If stack is empty, then stack underflow must be printed on the screen and we must exit from the program with exit failure status. If this is not the case, then we will print all the stack elements one by one with the help of this while loop, right? And in this main function, you can see I'm calling push function thrice, and finally I'm calling print function for the purpose of printing all the elements of the original stack. Okay, let's execute this code. The stack elements are 3, 2 and 1, right? 3 is the topmost element and 1 is the bottommost element, right? I hope the program is clear to you. But how to write a C code to create more than one stack? Now this is the question. Of course, we want to represent multiple stacks, right? Is it okay to have global declarations of top 1 and top 2 pointers? We'll find out the answer to these questions in the next presentation. Okay friends, this is it for now. Thank you for watching this presentation.